So today we're going to discuss about hard and soft water. Hard and soft water, you have already come across what is hard and soft water, so you might be familiar with hard and soft water. So hard water. So hard water is due to presence of calcium and magnesium. Okay. Calcium and magnesium in the form of hydrogen carbonate, chloride and sulfate. So salts of calcium, okay, salts of calcium and magnesium in the form of form of hydrogen carbonate, chloride, sulfate and in water. Okay, so the presence of these salts of calcium and magnesium in this form, okay, hydrogen carbonate, sulfate or chloride in water, is hard water. Okay, this presence of this makes the water hard. Okay, it does not lather with soap. So usually hard water, they don't lather with soap. That means they don't give bubbles, okay, easily. So what are soft water? So soft water means water that is free from all these ions, okay, from soluble salts, okay, or we can say ions, okay, of calcium and magnesium. Okay, I'm writing in short form. So those water free from these salts, okay, calcium and magnesium, are soft water. Gives lather with soap. Okay, there is one more thing. Okay, hard water forms scum or precipitate. Okay, I'm writing in short form precipitate with soap. Let's see the reaction. So soap, okay, are sodium salt, okay, of long hydrocarbon chain. So this will be positive, okay, this will be negative. Okay, so when there is positive and negative, okay, we call it as salt. So soap are long hydrocarbon chain. Okay, so in presence of salt, this M can be calcium, okay, or magnesium. Okay, so they precipitate means you will get a precipitate, okay, a product. So this arrow mark pointing downward means precipitate, okay, which are insoluble. Okay, so you will get a insoluble product. Okay, and 2Na plus, okay, as side product. Okay, so this insoluble product you can remove. Okay, now types of hardness: temporary hardness and permanent hardness. Okay, so temporary hardness. So temporary hardness, okay, is due to the presence of magnesium and calcium hydrogen carbonate. So the presence of magnesium and calcium hydrogen carbonate makes the water hard. Okay, the first, okay, we are going to see some methods of removal of hardness of water. Okay, that is temporary hardness of water. First is by boiling. So let's see the example. Magnesium hydrogen carbonate. Okay, so magnesium hydrogen carbonate, when we heat, okay, heating, or let's say boiling, okay, is converted to magnesium hydroxide. Okay, we get a precipitate and 2CO2. Okay, carbon dioxide is evolve. Arrow pointing above means it is evolve. Okay, evolve means release as a gas. Okay, next is calcium hydrogen carbonate. Same way, heating, what we get is calcium carbonate for this case, and then water plus CO2. Okay, so arrow pointing downward means precipitate. Okay, there will be, this product will be insoluble. Okay, and this insoluble product we can remove by filtration. Okay, after filtering, this product can be removed. Okay, and thus we get, as a result, we get salt water. Okay, so this is the first method. Now second method is Galgons method. Okay, so in this method lime is added to hard water. Okay, so let us see the reaction. Mg, okay, Mg HCO3 2 plus lime water. Okay, lime water is calcium hydroxide. Okay, this is lime water, so 2 moles of lime water to give calcium carbonate. Okay, plus magnesium hydroxide plus 2H2O. Okay, so when we add lime in hard water, okay, calcium carbonate is precipitated. Okay, magnesium hydroxide is also precipitated. Okay, so these two we can remove by filtration in the same way. Okay, like the first method in boiling oil, and we get water molecule. So calcium hydroxide, hydrogen carbonate again react with lime water. Okay, this is lime water to give calcium carbonate and water. So this is precipitated. The precipitated we can remove. Okay, since these precipitates, they are insoluble in water. Now permanent hardness. Okay, the reason for permanent hardness, okay, is due to soluble, okay, salts of magnesium and calcium in the form of chlorides and sulfates. Okay, so this permanent hardness is due to soluble salt, okay, of calcium and magnesium in the form of chlorides and sulfates. Okay, example MgCl2, okay, CaSO4. Okay, so this is for chlorides. Okay, this is for sulfates. Okay, calcium sulfate, magnesium chloride. So the presence of this makes the water a permanent hardness. Okay, is due to this. Okay, now treatment methods, okay, for removal of permanent hardness. Okay, the first one is treatment with washing soda. Okay, so washing soda you have heard, okay, before also in your class 10. So it is sodium carbonate. So calcium sulfate plus sodium sulfate Na2, not sulfate, carbonate. Okay, carbonate. So it gives calcium carbonate, CaCO3. Okay, this is precipitated plus Na2SO4. This is also precipitated, right? Sodium sulfate. Next is magnesium chloride plus sodium carbonate to give magnesium carbonate plus NaCl. Okay, so this will be 2. Okay, 2 NaCl. So this insoluble salt are precipitated, and we get after filtration we can get the soft water. Now Galgons method. So in this Galgons method, okay, sodium, I'm writing it, let's write it full form: sodium hexametaphosphate. Chemical formula Na6P6O18. Okay, so this is commercially called as Galgon. Okay, so this Galgon, okay, is added to water. Okay, and we will see some precipitate, okay, formation. Let's see. Na6P6O18. To Na plus Na for P6O18 2 minus. So in this molecule, okay, 2 Na is removed, so this become 2 minus. Okay, next, after getting this product, okay, this product will react with calcium, magnesium, okay, those soluble salt. Okay, M represents Ca2 plus, Mg2 plus. Okay, so it will react with those salt, okay, calcium or magnesium salt, Na for P6O18 2 minus. So it will precipitate, okay, as Na2M P6O18 2 minus. Okay, so it will get attached to this product. Okay, and you will get Na plus. Okay, 2 Na plus. So this precipitate we can remove, okay, and get the soft water. Now ion exchange method. So this ion method, exchange method, is also called as zeolite or Bernoulli process. Okay, so here hydrated, okay, hydrated sodium, aluminum silicate, okay, is used. Okay, so this hydrated aluminum silicate is known as zeolite. Okay, this is known as zeolite also. Okay, so let's see the formula, chemical formula: NaAlSiO4. Okay, so this is hydrated sodium aluminum silicate. Okay, so it is also written as, okay, this molecule, or is also written as NaZ. Okay, so all these, okay, aluminum and silicate represent Z. Okay, so we are going to use this formula, okay, in the reactions. So this sodium aluminum silicate is added in water. Okay, the reactions taking place, we'll see 2NaZ plus Ca2 plus, so it will give CaZ2 plus 2Na. The same way, 2NaZ plus Mg2 plus CaZ2 plus 2Na plus. So this precipitate we can remove, okay, and as a result, okay, we can get the soft water. This, okay, we can use this to regenerate the zeolite again. Suppose let's take M, okay, for metal, MZ2 plus NaCl. Okay, so when it is treated with NaCl, we can get back the zeolite, NaZ. Okay, that is NaZ. Next method will be synthetic resin method. Synthetic resin method. So this method, okay, is used nowadays. Okay, this synthetic method, or this is also a modern method. Okay, so this method is more efficient than the zeolite method. Okay, that ion exchange method. Okay, it is more efficient than the ion exchange method. Let us discuss now. So this synthetic method contain cation and anion exchange. Okay, cation exchange resin contain large organic molecule. Okay, SO3H. Okay, so this cation exchange contain this SO3H group and is insoluble. This is insoluble. So ion exchange resin, okay, RSO3H. So these are represent alkyl group. Okay, alkyl group means carbon hydrogen chain. Okay, long chain. Okay, it can be very long chain. Is changed to RNA. Okay, so this RNA means that DNA or RNA. Okay, this is not that one. Okay, R means alkyl group. Okay, so ion exchange resin. So this is ion exchange resin. Okay, is changed to RNA by treating with NaCl. NaCl. So this is okay resin. Okay, so this RNA, 2 moles of RNA will react with those salt, okay, either calcium or magnesium, okay, to give R2M, okay, plus 2Na. So we get an insoluble, okay, product, okay, which can be removed. Okay, so this okay, again can be treated with NaCl. Okay, this can be treated with NaCl and we can get back this, okay, again. Now pure demineralized, okay, mineralized, that means free from ions. Okay, now ions is present. Okay, water can be obtained. Okay, so pure can be obtained, okay, by passing water through, okay, so we'll come across those terms. Let's write one, okay, for easy understanding. Cation exchange. Okay, in the H plus form. Okay, cation exchange, resin, and anion exchange, okay, in the OH form, resin. So in cation exchange, okay, this H plus, okay, is exchange, okay, OH can exchange with those salts. Okay, let us discuss one by one. Cation exchange. So in cation exchange resin, okay, RSO3H, okay, in presence of acid becomes R minus H plus. Okay, so this is cation exchange resin. Okay, this is cation exchange resin. So 2 moles of cation exchange resin can react with metal, those calcium magnesium salt, okay, to give Mr2, okay, which is insoluble, okay, and 2H plus. So in this case, okay, H plus, okay, exchanges with either calcium, okay, magnesium, okay, or let us say sodium, okay, and other cation, okay, present in water. So this H plus exchanges this calcium magnesium, okay, cations, okay, present in water, okay, and form Mr2, okay, which is insoluble and can be removed. Next one is anion, okay, to anion exchange resin. So RSO3H, okay, treated with ammonia, we get RNH2. So this is anion exchange resin. Okay, so we use this anion exchange resin, okay, with water to get RNH3 plus OH minus. Okay, so these are NH3 OH minus, okay, can react with chlorides, sulfates, okay, those anions, okay, anions means negative charge, okay, those having negative charge, okay, X can be chloride, okay, hydrogen carbonate, okay, SO4 2 minus, etc. Okay, so these are NH3 OH, okay, this OH exchange with these anions, okay, in the reaction R to give RNH3 plus X minus plus OH. So this is precipitated and removed, okay. So in these reactions, okay, OH minus ions neutralize the H plus ions. So if you see, okay, what we are getting is OH here, okay, and H here, H plus and OH minus, okay. So OH minus neutralize the H plus ion, so H plus plus OH minus, finally you will get water, okay. So in this case, okay, we get water, okay. So that's mineralized water or deionized water, okay, demineralized or deionized water, okay. So water free from ions is obtained, okay. So exhausted, okay, anion or cation exchange, okay, this exhausted anion or cation exchange, okay, anion or cation exchange can be regenerated by treatment with dilute, okay, dilute, I'm writing in short form, acid and alkali solution. So alkali dilute solution, okay, like dilute HCl and all, okay, alkali NaOH, all those, okay. So with this we comes, okay, to the end of this topic.